Hi, I'm Zachary Angelat, and I'm going to be going over the gist of Go's interfaces. I wanted to start out by kind of explaining maybe how it sort of compares to other languages first, and maybe what it does, and then how Go sort of utilizes them. Other languages tend to use interfaces as like a contract, basically saying if you have these methods and these properties, then it's okay to use this object or class. You usually have to put some kind of word in front of them to implement that class or object, like implements. So it'd be like whatever the class name is, implements, keyword, or extends, and then interface. And usually other languages tend to use this for if you're trying to kind of make strict some kind of interface between maybe your services or even hardware, whatever it is that you're trying to do that needs some kind of restriction. In Go, because it auto implements, it's sort of restrictions, but it's also sort of about just being another type. And so the difference really is in other languages it tends to be like a contract. In order to call up this object in a parameter of a function, it better have these methods and properties. In Go, it's basically any object that has, or a struct that has these methods only, not properties, because interfaces in Go don't really care about properties. Maybe you could hack something, but they tend to not at base be that way. And so it's sort of, think about it in circles. If you have an interface that accepts a method that's usually used, like reader writer, then you're sort of building a bubble of things that can be passed in. Because the language is type strict, it's sort of a way to allow more objects in, right? Because if you're setting up a parameter in a function and beyond int or string or some kind of concrete type, but it's your reader type, whatever it is that you made, an interface sort of allows for, maybe if you have the reader method, then anytime you need to pass something into that function, just add the reader method to it. You tend to want to keep the use case pretty minimal. I mean, it generally should be used as a way to minimize things, but it can be used as a way to open up things in a type strict language to make them seem a little bit more dynamic. You want to be a little careful because you don't want all your parameters to have all the methods and allow anything in, because it sort of defeats the point. The more strict it is, kind of the less likely someone else is able to screw it up. If you're building a small little thing and it's just a web server and it's just for a personal site, it probably doesn't matter. But if you're working on a big team of people, it's probably going to matter. So when you try and make interfaces for Go, you can think about it as like this, and I like this sort of symbolism with it. I forgot where I got it from. Probably from some Go advocate or something like that online somewhere, podcast or something. I don't know. But think about it as, if you have a music hall and you have musicians, usually in other languages, if you use interfaces, and you can set it up otherwise, but usually you'd say, well, I only want a pianist, right, to play. And so you would set the interface on the pianist object, and therefore the only people who come in the door are pianists. In Go, it's basically auto implements on any object, and so you can put methods that most of your objects are going to use. And so it's like saying any musician can kind of come in and and play at that music hall, because that musician would be sort of the interface type, and so you can use that as a parameter. And by doing so, you'd be able to allow any musician to play that has that singing or whatever it is method that you apply to it. So to sort of sum it up, if you had, let's say, type musician, and we do struct, and use, I don't know, give it a name, and then let's say we had given it a certain method, and we would name it, play, sure. And this would, just to put stuff into it, it's really not that important, plays. Okay. And then we have the interface. So again, it's just type, and then, well, here, let's actually do this as, guitarist, right? And I want to leave that in because it's meant to make you think in those terms, sort of, and that's really important. This would be musician, but it would be interface type. And you can't put name in there, that ain't going to work unless that's a method. So you would put play. And so what we have here is like an object, you can think about it, guitarist, function play, and interface with the play method. So if we're gonna have, let's say, some kind of function service, right? And well, let's keep it to music hall. And let's, if we did this, right, that would be awfully restrictive to just that guitarist type. And I think this is how other languages would normally stop, in a sense. Not all, but I think the traditional ones. And they would say, well, music hall can only take a guitarist. If you want to have another one, you build another one. Well, Go sort of says, in a certain sense, and you could do this sort of with abstract types, but the problem is people never keep it to just behavior. Right now, the interface really doesn't use up that much data because it's just holding a method. It sort of, in a sense, is behavior. You can store data inside interfaces, and I'll show you that later, but you don't really want to do that. So there's a reason why they don't put properties inside interfaces, right? At least as far as the contract part goes, or implements part. So what Go kind of says is, that's awfully restrictive. I'm gonna widen that up. Even though in a certain sense it is restrictive, it allows for other players to play. So what I mean is, if you had, let's say, I don't know, keyboard, that's even what they're called. Right now, this keyboardist cannot be in a music hall. Cannot. Because it doesn't have play. So if you just add simply the behavior, right? And yeah, left it like that, sort of. Now you have the keyboardist part of the group, right? Inside musician, and so it can be put into music hall. So it's sort of, in a certain sense, has this as a type, kind of a underlayer, but it's not a subtype, because Go doesn't have subtypes, but it auto implements kind of outside of it. So musician technically doesn't know anything about keyboardist. All it knows is this method and anything that has it, or anything that utilizes play, I should say. Not, it knows the properties of what's going on here. And so this is sort of important because as you may, build these out and you're building a big service, you need to kind of keep a mental model of what's going on. And so being restrictive with musician, or the interface that you're going to use as a parameter, it helps because other people may make their own structs or their own code or whatever it is. They may want to use your service function, right? Well, there's a certain restriction on it, and it sort of keeps control, sort of winds the language as a TypeScript language, and keeps things simple. And I think the greatest benefit of all is that it minimizes complexity, because as much as you can start whipping things into types, as I'll show you in a bit, because you can make it complex if you really pushed it, and you shouldn't. This kind of gears you toward, at a base level understanding, more simple coding. And some people just go, oh yeah, it's simple, okay, yeah, I get it. Well, if you look at, your phone menu or whatever it is, or certain softwares that have grown over time, it gets ridiculous, it gets hard to use. I'd say a good example is like Pro Tools or something, where it's just menu on top of menu on top of menu on top of menu, and newcomers just kind of go, okay, I'm not. And then you see all these new programs come out that only have like 5 of the options that are most used, right? And people tend to gravitate toward those. And so that's the problem, right? And that's what this tries to address. And that's probably the most important aspect of Go interfaces, that it minimizes the complexity of adding things. And so in doing so, it isn't an abstract class that extends another abstract class that has certain properties that do a constructor that build a certain class that it doesn't turn into a God object. And that's what's really important. It inches toward helping you with a TypeScript language, yeah, and extends things. So it has the viability to turn into a God object, but it restricts things to the point at which they don't get out of your mental realm. And if you've ever opened up an open source project, you realize real quickly that is really important. Really important. If it's your own personal project, you probably don't care. If it's a one-off on your Raspberry Pi, you ain't gonna care. But when it comes to people working together, it makes a huge, huge difference. So, so when you try to utilize this function, let's see. Let's say, I don't know, musician or whatever it is. And, okay, so you have, let me get rid of all these copied versions. This ain't gonna help anything. I kept it simple just for showing sake, so to speak. But if you do have to initialize these in order to utilize them, right? So in a sense, they're like classes-ish. So you would do G equals guitarist, and then name. I didn't want to make it too crazy. And then let's say you do K for keyboardist. Again, name, Jill. And now you got to use these properties or initialized values. So this is where you would come across using the interface. And you don't actually use it itself per se, but if you use it instead of some kind of function service or whatever, it could even be another method, you can pass these in. And it doesn't matter. Now I'm not like returning data or printing out a certain kind of data. I do got to use both these values if I want it to work. You don't have to use both of these inside here. I'm just using them so that Go knows I use the variables. So if you then ran this, boom. So if you did, let's say we wanted to print k.name and then m.name and then because these, and this is an important part, it doesn't really seem like it's important, but it actually really is what you start to end up actually building is sort of like a package but in code form. And what I mean by that is m.play. Now if we were to have done, let's say, key play and G play, this would disrupt the contract, but if we were to add, let's say, that, and then they both have the play still, but I just extended the method, sorta, right? And I'm doing this to kind of prove a point. Because it has play, understands what's going on. If I were to do gplay, because let's see if it even pops up inside the language IntelliSense. No. And that's because the interface only cares about the method that it sort of utilizes. It doesn't care about the other methods, but you can still utilize it later on. So what I mean by that is, if let's say you take k.play works, gplay, you notice it's like what's going on, and it's going to have an issue with this, and that's because K, this type keyboardist, knows nothing about this one. Just nothing. Absolutely nothing. Nada. Doesn't know anything about it. But if you were to take, let's say, var I get guitarist, and you have it equal to that interface type, not equal, but utilizing it as a type, right? Now iGuitarist is going to know everything about musician, and so you'll be able to use iGuitarist, and I did sort of a crazy example here about all that. And so What you sort of have here is like a base struct type with just, the name property. And then you have an interface that has two methods, right? And that is the thing. If you were to take this interface and you were to do gplay, right? Now it knows about both methods. So what does that mean? Well, now you get to utilize them. But the thing is, the other type better have this method. And so if you were to put it on there, right, like that, now all of a sudden, when you go to utilize K or whatever it is, it has it because you put it on it, but it still can be used as the interface type. And so what I have over here's just two methods that it utilizes. When you use a struct and you use this interface, the IMean interface, and you embed it, now all of a sudden this struct gets all of its methods. I know that seems a little confusing because you're kind of taking abstraction, you're embedding it, and then there's more behavior somehow hidden underneath. Not really something you want to do in your normal day-to-day coding, but to understand different types and how they sort of interact, or what they know about, or how you can utilize them, or their behavior in general, it helps to understand what you can do with embedding and what you can call. So we take this struct and we embed it into another struct, just to kind of prove the point home that you can dig down and utilize behavior all the way down and sort of build this giant struct interface. Again, you wouldn't want to do this right off the bat or anything like that, but it can be done, and it's just a way to understand how things work. And you can call a variable with the interface type and have it equal a struct, because this interface utilizes the method that's on this struct. Now, this interface doesn't get the struct, right? But this variable now knows about both. So when you try to use the extra struct, which has the interface embedded, and you make it, you can actually initialize the struct that it has. I understand this might seem a little confusing, but the point is that this extra struct has this interface, therefore it has the methods that are embedded, but when you embed something, it has to be within that specific embedded order. And so this extra struct is in fact the struct, and in fact knows about the original struct, because IMean has the methods that the original struct has. I know that sort of seems weird, right? It's kind of like an inheritance thing, but it knows about it. So when you have the superstruct, which is this, that embeds the extra struct, you can begin to understand the different structs that are involved with it. It all has to be within a specific order. So again, wouldn't want to do it this way as far as what you're coding, because this is really confusing right off the bat. Anyone who looks at this is going to be like, no, I'm not touching this, and which is fine, but I'm just expressing the point that these types sort of know about each other based off the methods, based off the interface, based off of their behavior, And you can then call these methods off of things that have the types of these embedded types. I know, it's a little crazy. So you can do the same thing with these, and you can keep going if you wanted to. But the idea being that if it's a struct, it can hold data. It's basically the data. It's an interface. It's behavior. It holds behavior. And if they have something in common, you can utilize the type of it as if it has a struct. So it knows of it. It doesn't mean it is it. And therefore, it's sort of an implementation of behavior of the data, but you're just utilizing the types. So when you look through code, it a lot of times is best to not necessarily worry as much about the data or the certain behavior. A lot of times it's best to just glance and look at the types that are coming in and coming out. And this sort of simplifies what you're doing in hopes that they named it correctly, but it simplifies how you read code, because not only does it kind of ward off complexity, sorta, unless you abuse it like I did intentionally, but it allows you, when you read through really complex properties and behavior and everything, you can kind of get a sense of what it is you're actually working with, if in fact they named it correctly. And so you could say, in a certain sense, the simplicity can be abused and hide a lot of the complexity. And yeah, that's true. But you hope that there's no language that prevents complete complexity or abuse of the language, right? There's always trade-offs, and in doing so, people can find ways to wiggle their way into those. But it's not really something you see a lot in the wild in open source, where you have a struct that has an embedded interface that's in another struct that is utilizing the type interface. You really don't see that a whole lot. But I guess maybe a useful use case of this would be if you just had a giant program. Like, there's just no way to go through it all. You're never going to have a mental model of what's going on. And you need to tie one service to another, but it's a type strict language, and the programmers have a strict ruling saying, yeah, you can't change none. All you can do is add in your file, and that's it. Well, now you have an issue, right? Well, this sort of allows you to steal their behavior or the type's definition and work with it, which is pretty amazing to me. I don't know. And if you were to add the function type into all this, I think you'd have something that's pretty crazy, pretty abstract. If you had something that steals the function's behavior as an interface, as a type, with an embedded struct, you could really have some amazing behavioral abstract coding without having to code very much, which again prevents that whole over complexity thing, like I said, with like phone menus or certain software over time. Okay, I think I pretty much covered it all. If you have any questions, please let me know. All right, thank you.